Hello guys, today I'll be solving the last question from today's weekly contest. So here is the question. You have to find out the building where Alice and Bob can meet. Yeah. So let's see what are the given inputs. In input, you will be given the heights of all the buildings in form of array, right? And you will be given uh you are given some operation like how you a person can move from one building to another. Yeah, so there is a rule like one person can move to person from ith building to move to can move to jth building only if j is larger, right? So if like any people can move to the next building only, cannot move to previous building, right? Remember this way. And then any person can move to higher uh, higher building, right? So they cannot move to lower building, they cannot move to a building which has less height. And you're also okay, so you are given queries, and for each of the query you are given the index of Alice and Bob. So yeah, these two people Alice and Bob can move to a building where they both can meet, right? And to find out that, you have to find out their movements and where they can meet, right? For example, uh, if Alice at this one like 0th index and Bob at let's say first index. Okay, so can they meet at 0th index? No. Why? Because from first index you cannot move to 0th index. Lesser index you cannot move, right? Always j has to be greater than I. So they cannot meet at 6. Can they meet at 4? No. Why? Because the height of this is lesser, right? 4 is lesser than 6, right? So they cannot meet at 4 as well. But yeah, can they meet at 8? Yes. Why? Because they can meet from 6 to 8, they can move because 8, this height is uh, larger, right? And its index is also larger for 6 and for 4 as well. Height is larger and index is also larger, right? That's why. So for 0, 1, the answer is like 2, right? Because 8 is at 2th index, right? So similarly, you can do for other cases as well. So you have to remember that for given two indexes, you have to find out the indexes greater than the larger index or same as the larger index. For example, if you're finding for 6 and 8, right? So where they can meet? Can they meet at 6, 4? No. Why? Because 6 and 4 are the indexes where this person cannot move. Who is at this, right? Who is at it? So that's why they can meet either at 8 or they can meet at 5 or 2, because 8 can also move to those places. Obviously 6 can move to all the places, but you have to find out the person which are at l- larger index value, right? So one who is at large index value, so consider it, and the answer should be that index or larger than that index. So index wise it's clear, right? So you have to look at all these only, so large index. And then okay, so yeah, let's make some examples. Looking at the examples here, for the first query, yeah, as you have seen. So if Alice at Alice is at 0th building and Bob at first building, so they all both of them can move at this like second building, right? So 8 is larger as well as its index is more, right? And for 6 as well. Yep. So this way, if okay, so for the second query, so Alice is at 0th index, Bob is at second index. Then they both, where can they meet? Yes, 6 can move to 8, 6 can move to 7, but 6, yeah, 6 can move to 7 or 8. These two are options where 6 can meet. Yeah, 8 can be at 8, 8 can be at 7. So yeah, like 8 can be at 8 itself and 6 can move to 8. So both of these can meet at this point, right? And for the third query, 3 and 4. third index can meet at 5 or 7. This one, like third index can meet at this or this fifth index, right? Why? Because it can go from here to here because it's larger as well as its rightward, right? And at the same time, let's look at fourth index. Fourth index can move to nowhere behind, right? So it can move to this. It can be at this place as well. So let's see what is the common. Common is this place, right? So this Alice can move to this place and this Bob can also move to this place. Why? Because it's larger, it's higher, and it's at larger index. Right? Now, what we will do is we will always look for larger index again, and also we will always look for higher buildings. We will look for higher buildings and we will look for larger index. So higher buildings means from where I will compare. So maximum of maximum height of both, right? The building should be higher than maximum height of both. Uh, yeah, maximum height of both means it's not the height of Alice and Bob. Obviously, it's the height of the building in which Alice and Bob are residing, right? So the build right. So where they can meet is should it should be wherever they will meet. That building should have higher height, right? Yeah, there is a corner case as well. I'll talk about that. And the other condition is the index should be larger than or equal to as well, right? Maximum index of the both, right? Maximum of both the index, right? Alice and Bob, right? Yeah, these two are the conditions. Now you can think of the approach how you will derive the condition. So you can pause the video as well. Let's see how I have approached this problem. So I have used priority queue. Let's go to the solution. Yeah, I have what I've done is I have sorted the queries first, and not only overall queries. Also, I have for the convenience I have sorted the uh, height of uh, the buildings in which Alice and Bob are residing. So I have made sure that the first of the uh, height is a smaller and second of the height is always larger, right? So if first one is larger, then I have swapped it, right? So I have made sure that Alice's height is lesser than Bob's height, right? So yeah, it will not matter at the end, right? So if you will think of like it's just we have to find out a common building, but it's not. It doesn't matter where Alice and Bob is residing. Like if I and J is given, Alice can be at ith, then J at jth can be Bob. Yeah, vice versa can be also be good to solve. Okay, and then what I'm doing is I'm sorting. Yeah, I'm sorting on the basis of index. On the basis of index, then remember that what we are looking at. We are looking at for the buildings. We are looking for the buildings whose height is larger, right? So so I'm doing from which height? From which height it has to be larger? It has to be uh, higher than the maximum height from both of the two, right? So the maximum height will be for Bob, right? So it will be at one index, right? So I am just that's why I am sorting on this basis, like the higher building size. So one index for Alice as well, height will be larger, and for Bob as well, the height will. Sorry, it's not Alice and Bob. Sorry, it's just you can say it's X and Y, right? So the height of first query and height of second query, that you can say, right? So Yeah, so this will be the maximum height from first query, and this will be maximum height from second query, and you are just comparing that. Yeah, it should be in ascending order from the in the uh, in the respect of the maximum height for each of the queries, right? And obviously that will be Bob, because yeah, second one. Okay, then yeah, I'm just initializing the answer, and then I'm initializing a priority queue. Yeah, priority queue. Why? Yeah, we will see it later. Yeah, guys, one case that I missed probably. So yeah, I think this case where zeroth and second index were give the input, right? So this query, second query, right? This one. So for this query, you are seeing that the answer is this one. Why? Because uh, the second one can be at here, and this one can be can move to this, right? And if we will look at the higher, like I have written here, right? The higher building. So if we look at higher building, then there will be no answer, right? Because from 8 there is no higher building. So why it is the answer? Because yeah, you know that one can be immovable, one will not move, and other can move, right? So this will be a corner case here, looking at this. So that's why we are dealing it. Yeah, you can see it here, right? So in case if the second one, like Bob, is at higher value, right? Obviously, Bob is already, you know that the index of Bob is larger because we have already sorted, right? So index of Bob is already larger, and the height of Bob is also larger. In that case, they both can meet at both Bob's location. So that's why here we can directly keep the answer. And one more thing, if both the index are same, right? If Alice and Bob are already in the same building, then no need to move, right? So then also they both can meet at the same building. So these two are the corner cases. Okay, let's look at the overall. So here what we are doing is we have already sorted queries in the terms of indexes. Also, we are having priority queues, but yeah, priority queues will keep elements on the basis of uh, heights, right? So here it's the priority queue of pairs. You can see it. So pair of what? Pair of one will be height, max height of query, right? Max height of query, and the second index will be query index, right? The index of that query. Okay. So priority queue will be having the priority based on maximum height query. So it's not max heap. So we are having minimum priority queue. That's why the maximum height of for the same query, but overall it will be uh, it will be declaring the minimum of all the uh, queries that it will have at a certain moment, right? So let's see how it is doing. So what it will do is, okay, let's go to the diagram once again. Yeah, let's see if the queries are sorted as we wanted. Yeah, it's sorted. Why? Because the maximum index are already sorted. 0, 2, and 4. Yeah. These are indexes of the buildings where Alice and Wows will reside initially, right? So yeah, uh, these are sorted, queries are sorted, these heights are as it is, right? Then what we will do is we will look at the queries, and for the queries we will look at the buildings which can serve as a meeting point. What we will do is we will look for all the buildings before my current query, if those buildings can be served to have a meeting point, right? So here we will start with this building, okay, zeroth building. Why? Because my query has 1 as maximum height. So for all the buildings which have a height less than this maximum height, we will just process. We are not looking for any building which has a higher height than this. Why we are not looking for the higher buildings uh, from this? Not, sorry, not higher buildings, it's larger index buildings. Why we are not looking for larger index buildings? Because we know that we are going to serve the queries we have already kept at priority queue. So we are using priority queue to keep queries maximum height. So priority queue significance is max height from queries. Okay. So the for the first step, we are not serving queries directly, right? So we are inserting the queries into the priority queue, and we are looking at the buildings. For each building, we are looking we are trying to find out the queries. Okay. So instead of trying to find out building for a given query, we will be finding out queries for a given building, right? Yeah. So we will be at, for suppose we are at index 2. Okay. So for index 2, we will be finding out the queries which this building can serve. Okay. So this way we are solving it. So for example, if we are at this building, the zeroth index building, then what queries we can serve? We can serve for any queries where the building is less than 0. Okay. Yeah. The corner cases we are not looking at now. So we are just looking at the cases where both Alice and Bob's has to move out. Okay. So yeah, for zeroth index, we have to look at all the uh, for zeroth index building, we have to look at the queries where the maximum index is lesser than 0. Nothing, right? So then comes to first index. First index, we will look at all the queries where the index of maximum value is less than 1. So all there as well nothing, because yeah, it's 1, but 1 is equal to 1, right? It's not lesser than 1. So yeah, no queries has been served as of now. But yeah, we are pushing it in the okay. uh, let's see if we have to push something into priority queue as well. Nothing. I don't think anything. Let's go further. No, nothing has been pushed into priority queue. Then we are coming at this index 2. Okay. At index 2, we have one query. This query. Okay, 0 1. So this query I'll look at, and then we will see that yeah, this is the query where uh, the height is maximum height of 0 1 is what? Let, so in we will be writing the maximum height as well. Yeah, now comes the priority queue. Sorry, let's. I think I have missed height priority queue thing to mention properly. Okay, so let's again go. So we will be doing two things. We will be inserting into priority queue based on like equal values of index, but we will be serving a building for lesser values of index. So you can see at the code, right? So here we are looking for the we are going to serve for serve a, using a building. We are going to uh, traverse a building to be able to serve for having an index lesser than current query, right? It's just lesser than current query. But again, then we are obviously taking our current query only into the priority queue, and we are having the maximum height, right? Maximum height is obviously of uh, Yeah, obviously of Ellis. Why? Because if it has to be Bob, then already you know it's corner case, right? I think you got it. So anyway, anytime if there are two given indexes, and if the second index is having higher height, obviously that will not be into priority queue. That will be served right away. Okay, so like this one, 02. Okay, eighth is higher and it's served right away. Okay, so let's once again I'll do it very fast. Okay, so here first thing is I am at zeros index, nothing to do. Okay, there will be no query as well at this index, right? At one, nothing. One is not going to serve any of the query, but yeah, here at one I have to push one query, right? One query at my height, right? At one, and that query has to be pushed with my current height, obviously. So that is 6. Why? Because it's not one is the index of this query. Okay, for this query, I have to write index. For each of the query, there will be index and height. And index height both will be maximum because we have to compare from maximum, right? Maximum index and maximum height. That's why for each query, I have to keep maximum height and maximum index. So first query, I'll have maximum height as 6 and maximum index as 1. Right? You can see from these two, you have maximum height, one is maximum index, right? So in priority queue, okay, in priority queue, you will have 6 as the maximum value with 1 as the index. Okay. Okay, not 1. Let's keep the index of the query is 0. Okay, so first query is there. Okay. And then you comes at second index. At second index, you look for all the query which has height lesser than 8. So 6 is having lesser height than 8. That's why this will be served. So this will be coming out and it will be served by which building? Currently at 2, right? So this second index building will serve 6. Okay. So 60 will be served by 2. Okay. Let's write it in. And then I come at third index. Okay. Let's see one more thing to do. At we see that this building has served one query. This is 01. Again, one more thing to do at this index, that is to push a query as well, because I can see one query which has index is equal to 2, right? So this will be pushed into priority queue again. Obviously, this was popped out when I have served already at second index. So the new thing that will be uh, pushed, that will be 02, and 02 is, yeah, okay. Once again, will it be pushed? No. Why? Because it is a corner case. We have already seen. Then next comes to the next query. Okay, it has already been served. Okay, by corner case. Let's keep it 8. Then we have come to third index. At third index, is there any query to be served? Uh, okay, is there any query to be served? No, because already priority queue is empty. Then we see if there is any query to be added into the priority queue, like to be added into queue. Nothing, because its index is 4, not 3. So we will directly come to the next index. It's 4, and at 4, is there any query to be served? There is nothing. But is there any query to be added into the queue? Yes, it's there, and we have added into the queue. This time my index will be 4, right? Larger index. And okay, so index will be 4, but height will be obviously 5. Sorry, so then I have to write in the priority queue maximum height and then the index of the query. So index of the query is 2. Why? Because it's third query, first query, second query, and this is third query. So third query, and it's 5 is the height. And we have Yeah, so this is what we have pushed into the queue. Then we come at the fifth index. At fifth index, we see is there any priority, is there any uh, query that we can serve? Yeah, so we have something in priority queue, but yeah, we have to check the height as well. So is the query height lesser than our own height? Yes, it's lesser. That's why then I'll serve it. Serve it. So on behalf of this fifth building. So fifth building, at fifth building, this query is going to meet 3 and 4, right? Because its height is more and obviously it's coming later. Yeah. Uh, this is obvious because we are moving forward only, yeah, and we are keeping queries from past. Okay, so since we are keeping queries from past, obviously index will be larger of my current uh, building, and again the height obviously we are checking through priority queue. And priority queue, why we are keeping priority queue as minimum priority queue? It's because we want to uh, serve any query which has eligible height right away. Like we do not want to keep any query pending, right? We want to, so minimum means we if we are make we are if we are taking out minimum from the queue, then it's sure that those minimums can be lesser than my current height. So it's greedy mechanism to pull out most possible case, right? So the most possible case will have minimum height, right? So if I have to find out some building, some queries with lesser height than 7, then I have to check out minimum heights first, right? We cannot check at the maximum height first to check if that is lesser than 7. We have always to check at the minimum height to find out something lesser than uh, my current height, right? So that's why we are using minimum priority queue, uh, keeping maximum height of the queries. Maximum height means maximum out of Alice and or Bob's height, right? So this way we are using priority queue. And yeah, at the last, when we are done with all the queries, right? All the queries, obviously we will keep in the queue, but it is possible that even after looking at all the queries, we may not have gone to all the buildings because some buildings can be coming after all the queries, right? So for those, I am just traversing more buildings, and for these buildings, I'm looking at the queue and finding out if any query or in that queue we can serve. Yeah, so those queries which will have height lesser than my own will be served, right? And served, how that is going to be served? Obviously we know priority queue uh, second value is always the index of that query, right? That's why, so this is the index of the answer as well, and we are writing the uh, index of the meeting point. Okay, so yeah, I think I've explained this when we are making keeping some building sorry, some query into the queue. So we are traversing each of the queues. Similarly, you can do something different as well. Maybe you can traverse on buildings, and for each building you can see what are the queries that you can serve instead of just looking at query and what you have to look at. I think, yeah, my logic itself says that, yeah, for each of the building you have to see what are the queries that you can serve. But yeah, uh, similar this can be reflected very same if you have this answer. Let me show you some different answer where I'm not traversing the query, but I'm traversing over buildings right away. Then we are doing something. Yeah, this way. So here I am. What I'm doing here is I'm traversing over all the um, buildings. Then I'm looking at the queries, and I'm looking at all those queries which can be served through this building, this current building. And then we are uh, we are looking at all the queries which can be added into the queue, and then we are serving many of the buildings. So yeah, these two answers, these two possible answers are there. Yeah, you can see which of these two uh, you you can be able to understand easily first. Yeah, so you can pause and take note of all these two and look. Yeah, this one especially because last one I have already explained. Okay, guys. Yeah, I'll put the link to the answer in the comment section. Thank you. Thanks for watching.